Simplifying fractions is a very important concept in fractions that sometimes is overlooked by students. But it's actually a very important idea, especially as we get to more complicated math. Simplifying fractions will actually simplify our life in these complicated problems. Now, before we can talk about simplifying fractions, we need to remember the concept of equivalent fractions, which are two fractions that are equal to each other even though they don't have the same numbers, like 1 over 4 and 2 over 8. We proved this in lesson 1.1, but let's do it again just as a reminder. We have 1 over 4, 4 is the denominator, so that means any shape with 4 equal parts. And 1 is on the numerator, so it means one of those parts is going to be painted. Then we have 2 over 8, 8 is the denominator, so let's make the same circle, but now in 8 equal spaces. And only 2 of them are going to be painted because 2 is the numerator. Let's paint them, 1 and 2. We know that these two fractions are going to be equal to each other because they cover the same part of the circle. They both cover the same part of the circle, even though they have different numbers. So this is what we call equivalent fractions. Two fractions that are equal to each other, even if they have different numbers in numerators and denominators. Why are we learning about equivalent fractions? Because the simplest version of a fraction is the equivalent form of it. It means we're going to turn a big fraction into a smaller fraction, but they will represent the same thing. We're going to turn a big fraction into a smaller equivalent fraction. But how do we do this simplify of fractions? We have 2 over 8. How do we simplify 2 over 8? We divide both numerator and denominator by the same number. We're dividing, in this case, both of them by 2. But it always has to be the same number. We cannot divide numerator by 2 and denominator by 5. No, it has to be numerator by 2, denominator by 2. Numerator by 3, denominator by 3. So it's always the same number. By 4 and by 4, 6 and 6, and so on. So then what is this? 2 over 2 is 1. 8 over 2 is 4. So these two are equivalent fractions, 2 over 8 and 1 over 4. And we just proved them, that they represent the same part of the square, of the circle. So this is how we get equivalent, simpler fractions. Let's put this into practice. Let's do 12 over 18. So we need to find a number that we can divide both 12 over 18. We don't want to get decimals, by the way, only integers. So we can divide both of them by 2 because they are even numbers. 12 over 2 is 6, 18 over 2 is 9. But we can actually go further. We don't have to stop there. Because 6 and 9, well, they're not divisible by 2, but they're both divisible by 3. So we can divide 6 by 3 and 9 by 3, leaving us with 2 over 3. So 2 over 3 is the simplest version of 12 over 18. They are equivalent fractions, but 2 over 3 is simpler than 12 over 18. Let's do it one more time. Math, the more we practice, the better we get. So 21 over 63, they are both divisible by 3. They are both in the table of 3. 21 over 3 is 7. 63 over 3 is 21. This is a simpler version, but we can actually still go further. We always go as further as we can. Okay? So, as far as we can. So, 7 is divisible by 7. 21 is also divisible by 7. And we get 1 over 3. So 1 over 3 is equivalent to 21 over 63. 1 over 3 is the simplest form of 21 over 63. And this is how we get the simplest version of a fraction. Remember, they are always equivalent fractions. But one more time, there is a second method to simplifying fractions. It is finding factors. It's actually the same idea. It's just like the concept of what we are actually doing. But sometimes it's actually faster doing this method. Let's write one of the examples, 12 over 18. Let's find the factors of 12 first. The factors of 12, remember this is prime factorization, are 2 times 2 times 3. only using prime numbers. 2 times 2 is 4, times 3 is 12. And let's do the same with 18. The prime factorization of 18 is 2 times 3 times 3, only using prime numbers. 2 times 3 is 6, 6 times 3 is 18. After we have it in this factor form, in this prime factor form, we're going to cancel the numbers that are repeated, so only repeated once. For example, these two are repeated, so we can cancel. I mean, we still have 1, 2 on the top, but we can only cancel it with one of the 2's in the denominator. So we have 1, 2 remaining there, right? We can only cancel 1 with 1, okay? We cannot cancel the 2 in the top with the 1 on the bottom. We can only cancel one of the 2's in the top. Then these 3's also cancel. We have a remaining 3 on the bottom, so we can only cancel one of the 3's. And what do we get? 2 over 3. So that's how we get the simplest form. We did it in the previous part of the video and we got the same answer. But let's do it one more time. 21 over 63. Get the prime factors of 21. 3 times 7. 3 times 7 is 21. Prime factors of 63. 3 times 3 times 7. Now we cancel. We have 3 on the top, 3 on the bottom. They cancel. We have 1 3 remaining on the bottom because we can only cancel one of the 3's. And we also have the 7's, which they also cancel. We are left with 3 in the denominator and nothing on the top. But be careful. When you have nothing on the top using this method, it doesn't mean you get 0 in the numerator. It means you get 1. So the simplest form of 21 over 63 is 1 over 3. And these are the 2 methods we can do to find the simplest version of a fraction. For more math lessons like this one, visit our website, mathusermanual.com, or follow us on Instagram at mathusermanual.